Knoxville Game Design, August 2019. Random Number Generators, RNG, with Jacob, Dylan, and Levi.
Welcome everyone to Knoxville Game Design for August 2019. This is a monthly discussion of our game projects and topics in the games industry. My name is Levi Smith. I'm in Oak Ridge, Tennessee. You may know some of my games such as TTY GFX Adventure and Kitty's Adventure. Also on the line from Lenore City, he's the creator of Shifty Shapes and other games such as Retro Future. It's Dylan Wolf.
Hey.
And it looks like also on the line we have Jacob. Are you there, Jacob?
I think so. Can you hear
me? Oh,
me?
okay. Yeah, we hear you loud and clear.
Cool.
Thanks for joining us. Yes, I really didn't have much for news this month, so I guess we'll just start out with a little bit of show and tell. I guess I'll start with Jacob. Jacob, did you have anything you wanted to show off this month?
I don't really have anything this month, sadly.
Okay.
I haven't been extensively working on anything.
Oh, okay. That's okay. Yeah, I think we have Ludum Dare coming up in October. They changed it to October, so that'll be early October. Dylan, did you... I know you've been working on a Pico 8 game.
Yeah, and I started after you did the bulk last month. I think you had it up. Do you want to show it, or do you...
If you want to share, you can share. That'd be
okay.
Cool. I'm glad the talk was useful, and I know I did put the slides out on Speaker Deck, and they should be linked on the main knoxgamedesign.org site too. So,
yeah, I don't think I went back and checked all those, but like you had a lot of research about like cheat sheet,
yeah,
and just the whole,
and
it was really nice because it X and A. Get the content game loop. The content and draw. So I made a match 3 game called got these blocks tiles, match 3 tiles, you know, in any direction, and then black tile, unlock something. But it's pretty much just a straight standard.
So it's kind of like columns. I see it there on the screen, and
yeah, I think I actually I played a game at a con a while. It's in PUZL. It has the block concept. I think that's
yeah, I've never seen a match 3 game where you have like a wild card color. I thought that was pretty cool because I didn't understand it at first, but I saw somebody else's comment. It's like, oh, the black didn't match, but the black block doesn't actually turn to a color block until it lands and you find out what color it is.
Right, and that's actually kind of lazy because the Tyson puzzle game that I remember seeing that mechanic in, it actually, like, you would see the color of the block. It was not active. This, I was like, I mess with multiple sprites. I just have one sprite, and if it triggered, yeah, it took a little while to get work. You know, if you've got any background, stuff like.
How did you handle the switching between the title screen and the game? Did you just like create 2 different functions for that, or?
Kind of. So what I did, I have this variable called block state, and block state is either dropping blocks are settling gaps, displaying an animation, showing the screen, start at the screen, and then what I draw an update. I go through, I draw the tiles on the board, background, draw the block. Then I'm keying off of like, okay, if we're dropping a block, then we draw. If we're on the title screen, draw the title screen there. And so, because it's a really simple game that works on the screen, I'm just toggling elements that tied to a specific
That makes sense.
state, dropping a block, then, block state 3, I'm just.
Oh, okay. Yeah, and I see you're using the update 60 method there. So I don't think we talked about that last time. But it seems like you might have had a question is like, is there any way to, like, in Unity you have time delta time.
Yeah.
And you can smooth things out that way. And I don't know if I answered that correctly last time, but yeah, I guess in Pico 8 you just assume it's 30 frames a second, or if you use the update 60 underscore update 60, then it's 60 frames a second.
And I actually used that. I originally wrote it with 30. I switched it over to 60 because that gives me way in how long it takes. Instead of going like, it takes 2 seconds to drop a pixel. Second, it takes 2 frames. Okay, well now it takes 5 or 6 frames.
Mm-hmm.
5, and it's a more gradual. Hit 100 blocks suddenly.
Oh yeah. Yeah, I know like GameMaker has a concept of a room speed, which is kind of like frames a second, where it's kind of like the same as this, where it's like, you can set how many frames, you just kind of lock it in, then you don't have to worry about doing the time delta time or anything, or calculating the current frame time from the previous frame time and using that fraction to smooth things out.
Yeah, and I put this on my itch.io in addition to.
Yeah, that makes things really nice where you can just bundle it up and make I think you get 2 files. One's in HTML, something.html, then a JS file. So you just take those 2 files and throw it up there, and it works pretty good.
Actually, I started a cartridge.
Oh, okay, cool. What did you think about the editor? I found the editor a little bit hard to work with.
I was okay with it. Like, I did find like P8 files are all text. You can actually check them in. I actually worked in the editor most of the time because that limiting, and it was easy to change something, iterate.
Yeah, I was wondering if you could like edit the P8 file directly, write your code. It seems like I tried that and I was like, yeah, this is a bad idea. I need to use the editor they gave me.
You actually can. For example, it's up in
like Notepad, yeah.
You're gonna see like a cartridge block.
Oh, okay.
And then at the bottom, you see the.
Yeah, maybe that's why I didn't try to edit the code directly in here, because like, I don't want to mess anything up there. But maybe if you just stay within that Lua block, that Lua section.
I actually, like on my desktop, I was working on, I think, one set of changes I hadn't checked. I was working on my laptop separately, and I actually made 2 changes. I had no.
Oh, okay. Very cool. Did you use, so for the blocks, you said you had 1 sprite for the blocks, right? Did you use like palette switching? I think I figured out how to do that.
No, I actually I had 5 sprites. I just didn't want to have a separate sprite for all.
Mm-hmm. Yeah. I found out there. is actually a command that you can't. I think it's like PAL, PAL, that you can use to pick one color and replace it with another color. But you got to remember to call PAL with no parameters after to reset your palette back to what it was before.
I guess it kind of works like clip. I know I use. Yeah, like you said palette up here.
Very cool. Yeah, yeah. I played it. And I think we found that one glitch where it wasn't doing the game. It's doing game over like a little bit early, and I know you went in there and fixed it.
Yeah, it was. I had to check if I had length.
Mhm.
Oh, you're trying to put animation.
Uh, yeah, that makes sense. Very cool. Yeah, everybody, you can check out. It's called Puzzle, PUZL, or
Yeah,
yeah, check out Puzzle on dylanwolf.itch.io. Find all of Dylan's games on there. Yeah, so I had a few things I was going to show off. First of all, I've been working on. I had an old Raspberry Pi, so I've been working on a new joystick. This is running RetroPie. I actually did a live stream of all this, but it's kind of like my old one. But I think last time I learned a lot of stuff. But yeah, I ordered all the buttons and joystick through Adafruit, and there's the Raspberry Pi in there. One thing I learned you got to watch out for is the GPIO numbers. I spent a lot of time figuring that out. GPI pin numbers are different than the numerical pin numbers on there. But yeah, I think I just need to put one more hole in the back, and so I can do the HDMI cable and power cable through the back, so I don't have to have this open. But yeah, it plays a lot of retro games. I'm thinking about, like I said, a live stream the whole thing. So I'm thinking about doing like a highlight video or time lapse or something of that. I want to see if it will run our Unity game. So this could be like the Knox Cade. I know that we talked about a long time ago, where you can take this to a conference and show it off, and it's kind of easy to play and everything, where people can just pick it up and play it and everything. But yeah,
I know you can get Raspberry Pis to run.
Oh, okay. Yeah, I think Mike Neal did something like that a few weeks ago.
Yeah, he had one. And simple cabinet.
Yeah, I think his like had a whole like screen built in, and I think maybe two joysticks and speakers and everything.
Yeah, I asked him about that a while. I can't remember. I have to look at. Told me where he.
Mm-hmm.
They make. Raspberry.
Yeah. Yeah, I guess the nice thing is, I mean, you can always just use the regular HDMI as well, so I can take this and plug it into any monitor as long as it uses HDMI. But yeah, it works pretty well. I used the classic Super Famicom button layout, the green, blue, red, and yellow. So this works really well for any Super Nintendo game or NES game. These are mapped to start and select up here. The only problem is if you're playing a game like F-Zero, where you need an L trigger and an R trigger, I don't have that on here, so that's the only thing this is missing. But yeah, I want to try. So I think you can, cause let's see here. If I'm assuming it's running Raspbian. I know it's running. It's got some specialized version of Raspbian, I think, with the I forget what it was called. But yeah, if there's a way to like run StartX and get a graphical desktop, then I'm thinking if you make a Android build of a Unity game, maybe it will run, maybe not. I don't know, but it's something I'll try out and play with. Yeah, the other thing that I actually got Hanafuda cards from Japan. So imported their Super Mario Hanafuda cards. So
Yeah.
they're really small. I didn't know they're going to be this small. I don't know, Dylan, if yours are bigger than this.
No, those definitely.
Uh,
It takes some getting used to. Like I said, there was a Kickstarter a while back for.
yeah, that's what I was expecting. I was expecting like regular playing card sizes. So I was a little bit surprised, but they're kind of nice because I can like set them all out on a table and they don't take up a lot of space or anything.
Yeah.
But I know we were talking about maybe for the next Ludum Dare kickoff, maybe make it a Japanese open game / kickoff thing.
Yeah. I can bring my. I have.
Yeah, that'd be very cool. Yeah, I think that'll be like October 8th. I'm not sure if there's going to be any other conflicts with anything that weekend, but we'll see. It's still like a couple of months away. Okay, I don't think I've been working on. Oh yeah, I have one game I was going to show. So I spent a little bit of time updating my Pico 8 game as well. It's the Space Shooter Improved. So I just added like a few more enemies. I kind of based this off a game called Titan Attacks. It's kind of like all the classic Galaga and Galaxans and all that. So I just added some additional enemies where they scroll left and right, and added some enemy shooting and some red enemies that take a couple more shots and everything. Yeah, and you can actually go to levidsmith.com, and I have it embedded right here on my website. So just play it right here. And yeah, they just kind of go back and forth. It takes a few levels before you get to the more interesting enemies, but changed the power ups and also did like a little explosion and added stars and things like that, added lives and all that good stuff.
But yeah, those parts. Seems like that.
Yeah, yeah, it's basically just using like sine and cosine and expanding the radius and things like that. It just gets mucky where you got to put everything in that one file. I kind of wish Pico 8 had the concept of multiple screens or something.
That would be cool.
Yeah, I really like Pico 8. I mean, it's definitely fun to play with. It just may be hard to get started with and everything. Also mentioned, I saw Joe Miller was working on his 3Tris game. You can find him at Double Square Joe on Twitter. I think he put it on the App Store. So I think he finally got that published. I haven't even looked at this, but it looks like he's got a leaderboard now. And some maybe updated the graphics a little bit more. So everybody go check out Joe's game. Yeah, I haven't seen Joe in a while, but it looks like he's doing well. I see pictures of his kids online, things like that. So okay, so the topic for this month is random number generators. So this is something I've been hearing a lot about, especially in the speedrunning community. I've been watching a lot of GDQ and things like that. And you always hear them complain about RNG, random number generator. So I was just going to talk a little bit about how that applies to game development and how some of that stuff is actually implemented. Let's see if I'm doing F5 here. There we go. Oops. Yeah, so first of all, this all comes from like real world examples of random number generators. Here's a few examples that came off the top of my mind. Like a dice, you roll a dice. A typical dice has 6 sides. You roll it and you get a number 1 to 6. A coin flip, I kind of think of that like a Boolean value. It can either be heads or tails, which kind of translates to true or false. The old Magic 8 Ball, and here I put it's sort of like a Boolean, because really you're looking for a yes or no answer. But I know with like the Magic 8 Ball, you can get ask again later, or this says signs point to yes and things like that. Drawing a card out of a deck randomly, and that's like getting a random card right there. Spinning a wheel, you never know where it's going to land. Here I have the example of Wheel of Fortune, or rock, paper, scissors is like, okay, 1 in 3 chance that you're going to get one of those outcomes. And I remember back when I was in school, we would have, like in our math books or statistics books, random number tables. So I looked a little bit into that. I didn't look deeply into it, but some people say, oh, you just turn to a random page and point at a number, and then you start pulling random numbers out of that. And you just throw out the numbers you don't need or replace duplicates, things like that. Yeah, I really wanted to look more into like how people generated random numbers before we had computers. I just ran out of time, didn't have much time to go to the library and research it. But I'm sure there's references out there if people are really interested in finding out the old way of generating random numbers. So first of all, I just looked at, like, okay, how do I, if I just want a random number from the command line, from a Linux command line, how would I do that? And here's some quick and dirty ways. I think I may have used this in the past before for getting a random number without like even using a library. 2 methods that I found. One is using the current system time. Most systems, you can actually return the system time down to the millisecond. And here I have an example here on Linux in a bash shell. You could use date and this plus. Oh, do you not see it? Oh, let me. Oh, okay. Let me. It may be because I'm actually. Do you see it now? Or okay.
Not
Let's
yet.
see. Oh, okay. I got you. Got you. Thanks for letting me know. Yeah, I'd already started. So here's the pretty pictures for the real world random number generators. And see if I can do F5 there. Yeah, so we got the dice and Magic 8 Ball and the coin flip and Wheel of Fortune. Hide that. And yeah, I didn't have much for the random number tables. I was wanting to find a picture in like a book in one of my old math books showing the random number tables, but I just ran out of time. Didn't find it. But yeah, right here to get the system time in milliseconds, you use date and use this plus %s %3n. The percent n returns nanoseconds, but I don't think all systems implement that. So you just want to return the first 3 numbers of that, which give you the milliseconds. So that gives you a pretty good just random raw number right there, because nobody's going to like know like what time you started your program down to the milliseconds. So what you can do is you can take that system milliseconds, then use a modulo, which is your percent sign, and use modulo of the range of numbers that you're looking for. So if I'm looking for a number between 1 and 100, I'll do system time milli mod 100. That will actually give me a number from 0 to 99. And to get that to be between 1 and 100, I just add 1 to that. So you just add the minimum min val in the range. You just add that to the number to the range. And if I want a number from 1 to 52, like I'm drawing a number from a deck of cards, I do system time milli mod 52 and add 1 to that. So a little bash script, and you can see an example there where this returned like the raw numbers 1564371926178. So pretty random number, just a current system time. You mod that and you get the number in that range. When I was doing 6502 NES games, I kind of did the same trick, but the 6502 NES doesn't have like a system time variable that I'm aware of. So I just kept track of the current frame, and that would give me a number between 0 and 255. And then after, so I just incremented that using this INX, and I had the variable in a thing called frame counter. So on every frame, I just incremented that. So it gave me a pretty good random value, as long as that's like based on some user's input or something. Like I had one game where objects would fall from the top of the screen. So whenever I would get the current value of the frame, which would give me a value in the range of 0 through 255. So I could randomly, and oddly enough, that's the same number of pixels along the top, number of columns of pixels that you have. So it's a good way to get a random value. There's probably better ways to do that, but it's a quick and dirty method that I use. So here's a few examples of getting random values. I'm going to start off. I'm going to show 3 different programming environments, game development environments. I'll start out with Unity, and I'll also go over GameMaker and Unreal Engine. So for Unity, we're going to do this in C#. So for a coin flip, we're just going to have a Boolean called isHeads, and I'm going to have that set to false. Then I'm going to get a random integer. So I just call random.range and specify 0, 0, 2 as the parameter. So that's a exclusive upper bound. So if you do 0, 2, that's going to give you either a 0 or a 1, and that's going to be a 50-50 chance whether you get a 0 or a 1. So I have a if statement right here. If random equals 0, then isHeads gets false. If it equals 1, I could have just did an if statement or an else right here and left off the random equals 1, but we're going to set it to true. And then in the output, if it's head, we're just going to put heads, and then if it's not heads, we'll put tails. So here's our debug output down here. So you're going to get a random heads and tails. And I have all this in an example project. I'll post that online so everybody can get the source code. I actually have this tied to a button, a Unity UI button. So every time I click that button, it calls do coin flip and prints out either heads or tails. Here's another example of rock, paper, scissors. We're going to do the same thing. We're going to assign this random value to random.range 0 to 3, or 0, 3 is the 2 parameters. So we're going to get either a 1, 2, or a 3, all 33% chance. So instead of doing an if statement, this time I used a switch statement. So it's really up to you whether you want to do a switch or an if statement. So here I use a switch statement on random. So if it's 0, we're going to print out rock. 1, print out paper, or if it's 2, we'll print out scissors. So here's the output down here, so you can tell you randomly get paper, rock, or scissors. If we want to do a dice roll, I have this function called do dice roll. I have 2 variables defined. I've got the same random variable here, which will be the rolled value of the die, and then a sides value, which I use as a parameter to the random range function to tell it how many sides. So I use random range, then as the 2 parameters for the minimum, I use 1 because we want to value 1, 2, 3, 4, 5, or 6. Then I add the number of sides as the second parameter, but I want to add 1 to the number of sides because remember that upper bound is exclusive. So this will give us a number 1 to 6. So yeah, whenever you press this, it's going to say 6-sided die, you rolled a 5 or a 3 or something like that. In the second example down here, I set the number of sides to 20, and I used the same exact call, random.range, and pass in 1, and then the number of sides, which in this case will be 20, and add 1 to that, which would make it 21. So we want a number in the range of 1 to 21. The top bound is exclusive, so we'll get a number 1 to 20. So it will, in the debug console output, will print the value. So in here, this example, I rolled a 16 or I rolled a 12. And here's a little bit more complex example of drawing cards from a deck. There's a couple of different ways you can use this, but first of all, what you want to do, what I did is I created a card object. And basically in this card object, I'm just going to have 2 values defined, a suit, which is like spades or diamonds or clubs or hearts, and then a rank. And rank is basically the number on the card. I think this is like the French or something card, your standard poker playing deck. If I was really going to turn this into a game, I would probably actually even assign a value to the rank, because otherwise you wouldn't know if an ace is a 1 or if a king is a 10, what the value of that actually is. But for this example, we're just going to call it rank, which is a string. Then I have a toString method, so I can just call toString on this card object, and it's going to display what the card is. So first of all, I have a makeDeck function. So I'm just going to make a list of cards, your standard C# new list, and in angled brackets, we're going to put cards, so it makes it a list of cards. So this is going to be a completely empty list. So then I'm going to loop 4 times for the 4 different suits, and then 13 times for the 13 different cards. So those are 2 nested loops, and each time it's going to make a new card. Then based on the iterator, I guess, it's going to assign either the spade, club, heart, or diamond to the suit. And then based on the second iterator, it's going to assign either jack, queen, king, ace, or the number value if it's actually a number value card from 2 to 10. So then after it creates a card, it's going to add it to that list. So we're going to end up with a deck of 52 cards in that list. So here's where I've been thinking about this a little bit. 2 different alternatives for getting a random card out of the deck. The first approach is you can actually shuffle the deck, and that's what I have in this example right here. Shuffle deck. So after you make the deck, you're going to shuffle it. And I remember talking about in a monthly meeting a few months ago about Big O and runtime execution. And I think ordering a deck of items in a new array is like a big O of n. It's just like a linear operation. So basically what we're going to do is create a new temporary list called the shuffled deck. Then for every item in the deck, we're going to pull out from a random location and put that in the shuffled deck at the first position. That's what add does, just puts it in at the first position. Then we're going to remove that card from the old deck since we've added it to the shuffled deck. So we're going to keep pulling cards from the old deck and put it into the shuffled deck until we no longer have any cards in the old deck. So then whenever we start playing the game and we want to draw a card, we just go to our new shuffled deck and draw a card off the top from position 0, from right off the top, and return it, print it, called the print string on, or the toString method on it, and that will say, okay, deck, how many cards are left in the deck, and the name of the card that is printed based on that toString method. Now, the other method, which I don't have listed on here, is to not shuffle the deck to start out with, but whenever you want to draw a card, just draw from a random place in the deck. So that may be a more efficient method, because I believe that would be like big O of 1, because you're going directly to a place in the deck and drawing a card. I like the shuffle deck method. It may be more processing intensive because you actually got to perform that shuffling operation and you're creating a whole new list and things like that. But it makes it easier to draw a deck from the card. You just draw it from the first position.
It also, if you had a game mechanic related to the deck, it would allow you to go in, show me the top 3 cards, put.
Yeah, that makes sense. It just seems like the shuffling before makes more sense. That's the way things work. I mean, if you're actually doing this for real, that's the way I would do it. And that's a lot of the way that I code things is like, oh, how would you do this in real life? But yeah, I think that's a good point. It's like, okay, I want the top 5 cards. So just give me 0 through 5. So doing the shuffling beforehand, it puts a little bit more processing on the front end, but you don't have to worry about generating random numbers and drawing from random positions.
You can do a lot more mechanically with the deck as a whole.
With it already shuffled, yeah. Yeah, so yeah, I think that's a very good point. So, but it's really up to the developer, however they want to do it. Like most things in game development, there's many different ways to skin the cat. So, okay, so here's some GameMaker examples. If I can, okay, I got the hang of Shift F5, so I don't have to go back to the game. So in GameMaker, if you want to do a coin flip, so in GameMaker, you basically have different, they're kind of like methods, but you have like a create, then you have in here a left press and a draw GUI. So all the drawing to the screen is done in draw GUI. But in your create, I'm just going to set up a variable called coin value. And whenever you press the left button, I do have like a separate object that I have all this assigned to, which has a sprite, which the sprite just says coin flip. So whenever you click on this coin flip, it's going to call random. So there's a few different random methods in GameMaker. So I think just random will return a like floating point value. But if you want an integer value, you use random. And that will, it assumes like the bottom number in the range is 0 always. It does. You may be able to pass in a range, a lower value. I'm not sure. I'll have to look into that. But basically, if you call random 1, it's going to give you a 0 or 1. Each one's 50% chance you'll get either one of those. So I assigned that into the flip value. And then like in the other example, if it's a 0, then I'm going to assign tails. And if it's 1, I'll assign heads. And I'm actually building a string out of this, which isn't really efficient, but just for this demo, I wanted to show a history of the heads and tails flips. So I put in a new line character at the end. So every time it's just going to append that flip to the end. So you can see I just pressed this multiple times and it has heads, 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 tails, heads, tails, tails, tails. If you want to do rock, paper, scissors, I do the same thing in the create. I just have a value string that starts out empty, and then I have a random variable that I'm going to assign random to. So I'm going to get a 0, 1, or 2. And GameMaker also has a concept of a switch statement. So I just pass in that random value, whatever's returned from random. If it's a 0, I'm going to append rock. 1, append paper. 2, append scissors. And after every case, you want to have a break statement. And it's also, I didn't put a default in here, which is technically it's good to always have a default statement. And I just don't have it in this example. So yeah, and then I guess, I don't know if I mentioned it last time, but there's a draw GUI method on your object. So it's just going to take whatever's in that value string, and it's going to draw that to the X and Y location that you specify. So I just have that result and pass in that string value. So you can see here, every time you press this rock, paper, scissors, it's going to return scissors, paper, scissors, rock, rock, scissors. So for a dice roll, we're going to have 2 variables. First one is the 6-sided roll, and the second is the 20-sided roll. I'm just going to set those to -1 to begin with. You could actually use that to say, oh, if it's less than 0, don't display anything to the screen. So for the 6-sided roll, I'm going to do random 5, which is going to give a value 0, 1, 2, 3, 4, or 5. And then I'm going to add 1, so it'll be 1 to 6. And same for the 20-sided roll. I'm going to have 1 plus random and pass in 19, which gives me a value from 1 to 20. So every time you press this, it's going to roll. In this example, I rolled a 4 for the 6-sided dice and a 14 for the 20-sided dice. And I use draw GUI to output that to the screen. And there's some other options you can use in the draw GUI method. You can set the text color using draw text color and pass in the C_yellow or whatever color you want for your text. And also I set up a font type or a font object, or font resource, and you can specify what type of font that you want this to display in. Okay, so I had to go back and dust off Unreal Engine. It's been about a year or so since I worked in Unreal Engine. I'll admit I don't know. I know some C++. I don't know how to do C++ in Unreal. I have never figured out how to do that. So I always use blueprints, which is nice because it's visual. It's kind of like Playmaker, where you take these boxes, these different states, and you wire them together to do your different logic. So it makes everything, it makes it easy to look at and interpret than looking at lines of code. But if you get into some complex operations, it can make things a little bit more difficult. So right here, a coin flip. This C right here is whenever it's an input, keyboard input C. So whenever that's pressed, then it's going to pull this random Boolean that I had defined. It's called isCoinHeads, kind of like in the previous example. So it's going to get that Boolean value, and then so basically they have a branch statement. So if it's true, then we're going to print string heads, but if it's false, then we're going to print tails. So every time the C button is pressed, then it's going to get a heads or a tails value. But I don't see in this picture right here where it's getting the random value. I do have it over here in the dice roll. So this coin flip is missing one piece of information. So I'll try to update the slides. So if we look at the dice roll, we have a Z block right here. So that's going to fire off every time the Z is pressed on the keyboard. And it's going to pull this value called I six-sided in. So we're going to generate using this random integer function. And similar to the other programming environments, we're going to pass a 6, which generates a value from 0 to 5. The 6 is exclusive on the upper bounds. Then we're going to add 1 to that, which gives us a value from 1 to 6. So we're going to take that value, and it's got this build string block right here, and that basically just converts your integer to a string because the print string wants this text value right here. So every time I press the Z button, then it's going to do a print six-sided roll and then a value from 1 to 6. So in all these examples, we assume that the library that it's using, or under the hood, when we're calling these random functions, it's a truly random variable. But there's ways that you can like constrain what random values are returned. And so there's a concept of a random value seed. And this is a pretty old concept. I remember this all the way back in my QBasic days. But if you want to generate the same set of random numbers every time, most development environments have a concept where you can set a seed. In Unity, you use random.init state. And you can see that right here in this middle column. And you can pass in an integer value. So if we do just a random print numbers, which I have here on the left, and print 10 random numbers in the range 1 to 100, then it's going to give you a different set of numbers every time. But if we pass in the seed value to the random.init state, then it will give us the same numbers. Like here we have 74, 97, 41, 74, 97, 41, 97, 41 every single time. So it's pretty nice to be able to, especially if you're testing and you want the same behavior every time. I'll just say it makes things easier to test sometime. Another good use for this, which I haven't done myself, but I remember like having discussions about this years ago when I was making a Tetris game, an online Tetris game, a network Tetris game, and you want both players to get the same set of blocks. Well, you can have it like on a server. You can generate a random seed, then pass that random seed to all the clients, and that will ensure that all players are getting the same set of random numbers every time, which I haven't done that yet, but I want to give that a try. I think it'd be a good way to solve that problem of ensuring that each player gets the same values. In GameMaker, to set a seed, you use random underscore set underscore seed. So in these examples, I just passed in 1337, but you can make it whatever value you want. So here's another concept when generating random values. You can either use completely random numbers, or I think this originated in Tetris. It's the bag method. So in the old school, really old versions of Tetris, you would just get random blocks every single time. But using this bag method ensures that you're getting a more evenly distributed sequence of pieces. So the concept is you have this bag, which is just a list of pieces or integers. And when the bag is empty, you're going to load the bag up with the 7 different Tetris pieces. So when it's empty, you load it in with 7 pieces, then you draw from that bag until that bag is empty again. Then you load it in with the next 7 pieces. And the benefit to this, it prevents runs of getting the same pieces over and over again, or going on droughts of certain pieces. It seems like whenever I played Tetris, I never did get the eyepiece when I needed it, but that was in the old version of Tetris that didn't use this method. The one thing about the bag method, it is possible to get one item twice if that item is at the end of one bag and the start of another bag. So it doesn't ensure that you won't get 2 items in a row, but each set of 7 items in this Tetris example will be unique. So yeah, here's a picture of it right here. If I'm doing a completely random pool from the 7 pieces, like I got these, I think these are like Z pieces. You might get 2 in a row, then a box, and you might get some more like boxes in a row here. So it's just a completely like random sequence of pieces right here. But using the bag method, I'm going to get all 7 of these pieces. I'll get a J and a Z and an O and an S and an I and a T and an L. Then after I go through that bag, then I'll get the next set of 7 pieces, which are in that set. So this is actually a game of Tetris that I played right here. And then in the old NES Tetris, it would actually display the statistics on how many times that you get each piece. So here I got like 5 Z's and 3 S's and 0 or 3 O's, but I didn't get any I pieces or any T pieces. So if the old version, if the NES Tetris version of Tetris used a bag method, then you would at least be guaranteed an I piece every single 7 draws. So here's a quick example that I did of the bag method. Pretty simple right here. This is just going to generate values 0 to 6, 1 for each piece. So whenever you have a list of different pieces, which I'm, like I said, just using integers here. So it's going to be a list of ints, and when it's started up, we're going to have a piece bag, which is your list of integers, and make a new list right there. So it's going to start out empty. So when I press this get piece button, first thing it's going to do is going to check if the piece bag, if the number of items in it is 0 or equal or less than 0. If it's 0, then we're going to refill the bag. So that's a separate method down here. So we're going to drop down and say refill bag. So that's just going to do a loop 0 through 6 and then insert each integer into the bag. And we're going to put those in random locations as well. So we're going to use random arrange 0 and then the current bag size and add that integer. So we're going to get 7 items added to the bag at random positions. So then after it does that, we're just going to draw one of the number off the top and add it to the pieces display right here. Then we're going to remove that piece off the top of the list. So here's the example over here. Each time it's clicked, and then it's just going to print out these numbers. Like here's 214-530-60. Then we're going to start over again 156-3240, and then it starts out with another sequence like that. So I want to talk a little bit about probability because it kind of goes along with randomness. Here's a screenshot of me in my World of Warcraft days. One of the big things was getting the epic loot after beating a raid boss in World of Warcraft. So I was like, okay, what are my chances of actually getting that drop? So I just use like a simple example here. If you roll 2 dice, each dice, from a standard dice, has 6 different outcomes. So if we're rolling 2 dice, what we do is take the 6 outcomes from the first dice, multiply it by the 6 outcomes of the second dice, so you get 36 total outcomes. So the probability of rolling a 12, which only occurs once by rolling 2 6s, since this only occurs once, we're going to put 1 over 6 times 6, which is 1 over 36, so it's 2.78 percent chance. So this is something good to be aware of when you're developing a game and you're using random variables. You want to make sure that if you're generating a number, then it's within a certain range that it makes it fun for a player. If you have the outcome like so low that it's never going to happen, then people aren't going to find that very fun. Here's another example, the probability of rolling a 7. There are 6 different outcomes for rolling a 7 on 2 dice. You got 1 6, 2 5, 3 4, 4 3, 5 2, and 6 1. So in this case, we take the 6 different outcomes that we're looking for, which is rolling a 7, and divide that by the total number of outcomes. So that's 6 over 6 times 6, 6 over 36, which reduces down to 1 over 6, which is 16.67% chance. So if I was making a game, I might make it like 16% chance for getting an item instead of a 2.78. It all depends on what game you're making. There's another concept called combination. So if you get into like high school math or college math, you'll hear about the concept of combinatorics and combination. So if we want to know out of a 75, I'll use a Hanafuda card deck here, 75 different cards, how many different combinations are there of drawing 8 cards out of that? And the thing you got to be aware of with combination, the order doesn't matter. So if you like have your Moonlight viewing card or whatever card, it doesn't matter if you draw it first or if you draw it 8th. It just matters if you draw it somewhere. So there's a operation called choose. So N is the total set of cards that you have, and each card is unique in this case. And then another value called K, which is how many items out of that set that you're drawing. So it's called N choose K. And what we do, N choose K, that's defined by N factorial over K factorial times N minus K factorial. And I explained what factorial is in the Math for a Game Developer talks a few months ago. So basically, if you have 3 factorial, it's 3 times 2 times 1, which is 6. Or if you have 8 factorial, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So yeah, if we have 75 total cards and we choose 8 out of 75, it ends up being 16 billion, roughly 16 billion different outcomes. So the chance of drawing a specific combination of 8 cards is 1 over 16 billion, which is really low percent chance. I did break out my old TI-85 calculator right here, and it actually has it's kind of hard to see. The picture didn't turn out very well, but there is an NCR, small n, capital C, small r operation that will give you the value on the TI-85. So similar to combination, there's actually permutation. So what makes permutation different than a combination is in a permutation, the sequence is significant. So order does matter. So for it, we have it represented by this P, then an N and a K. It's similar to combinations. The N is your total set size. K is the number of items that you're selecting. So the permutation of NK is N factorial over N minus K factorial. So a real game example of this is, let's go back to Tetris. If we're drawing, or if we want to know the probability of getting a certain 2 draws for the first 2 drops or first 2 pieces out of 7 in Tetris, Well, that's defined by the permutation of 7 and 2. So that's going to equal 7 factorial over 7 minus 2 factorial, which reduces down to 7 factorial over 5 factorial, which is 5,040 over 120, which is 42, which makes sense. That also equals 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2.1 times 1. And the multiplication of 5 down to 1 cancels out. So it's 7 times 6 is 42. And that makes sense. If you're starting out with 7 different pieces, well, the probability of getting one of those 7 pieces to begin with is 7. Now you're left with 6 remaining pieces in the bag. So the probability of getting a specified piece on the second draw is going to be 6. So that's 7 times 6 equals 42. If we're not using the bag method and we're just randomly generating one of 7 pieces every time, then it's 7 squared, because in that case we may get 2 I pieces to start out with, or 2 T pieces to begin with. So that's 7 times 7, which is 49. So that'd be 1 over 49, the chance of getting the specified 2 first pieces. So here's another example, the probability of getting a certain sequence of 5 pieces in Tetris using the bag method. Well, that's going to be the permutation of 7 and 5. And you can see the math here. I'm not going to say it all here, but yeah, it's 7 factorial over 2 factorial, which is 5040 over 2, which is 2520. And you can also do the same reduction method down here. The 2 times 1 cancels out on both of these. So it's 7 times 6 times 5 times 4 times 3, which is 2550. If we don't use the bag method, then it's 7 to the 5th power, which equals 16,807. So you can see the bag method significantly constrains the number of possible outcomes, 2520 to 16,000. So it gives you a little bit more even distribution. Yeah, so that's basically all I had for random number generation. I didn't have any other real news for this month. Is there any questions about random number generators?
I can't think of any.
Oh, okay.
I mean,
I can't think of any either. So.
Okay, well, hopefully it's helpful, and yeah, hopefully I'll post all the examples out there if anybody wants to use that as a reference for any of their games or anything like that. Yeah, so yeah, everybody, you can find us on knoxgamedesign.org. You can find Dylan at dylanwolf.com and on social media, Dylan Wolf. I'll post Jacob's on, I think he's Big Ol' Tom on Game Jolt.
Yeah,
Yeah, and you can find all Jacob's Ludum Dare games and past games and things like that on there. You can, and
not all of them are on there.
Not all,
but there's just a few.
Yeah, I think we have links to both your Ludum. So your Ludum Dare entries are actually on the LD Jam site, right?
I believe so.
Oh, okay. So yeah, you can find Jacob's games. He's Jacob Turn on LDJam.com, so you can find all his games. Check them out there. I'm Levi Smith. You can find me LeviDSmith.com, GA Tech Grad on social media. You can get the podcast for this show on iTunes or Stitcher and Google Play and other places. And also you can get the video of this, which I highly recommend if you want to see the slides, on YouTube, and maybe posting those to a few more places as well. But anyway, I think that's going to wrap it up for August 2019. We'll be back next month with a new topic, and then I think in October we'll probably do, depending on how many people do Ludum Dare, we'll do a show off in October for the monthly meeting. So anyway, until next month, thanks everyone for watching.